So in this video we're going to be proving that A plus B equals Y for the angles in this given diagram. So as we can see here, we've got the angles labelled. In the triangle there is a right angled triangle, and we have some known lengths which are the same. So the very first thing we're going to do in this situation is we're going to let AB, which we know is some length, denoted by the two dashes there, equals BC, some other length, which is also the same length, and CD and DE all equal 1. So they're going to be 1 unit in length, all of them. Now, the next key part is that tan theta, so the tan of any angle, is equal to opposite over adjacent. So what we get from here is we got a right angled triangle, because we know we've got a right angle in the corner. So we can work out that tan of alpha is going to be 1 on 3, because we take the opposite side from the angle, which is length DE, 1, as you can see there, and then we have the adjacent side, which is AB plus BC plus CD, which is 3. So we know that the tan of A, we can see that that's the leftmost angle, is going to be equal to 1/3. Now tan of B, or beta, is going to be a half, because of a similar reason. We have DE as 1 as our opposite, and then as our adjacent we have 2 lengths, each of which are 1. So we're going to have 1 on 2 for tan beta. For tan of Y, we're going to have 1 on 1, because we have length DE equaling 1, and then we have length Y also equaling 1. So we're going to get 1 over 1, which equals 1. So now we need to look at tan A plus B as a identity, so a addition formulae. So what we actually get from there is we know that tan A plus B is going to be equal to the sine of A plus B on cosine A plus B. And we know those two identities, so we're able to expand them. Of course, we know that sine A plus B is equal to sine A cos B plus cos A sine B. And then we know that the cos of A plus B is cos A cos B, takes sine A sine B. And now we need to be able to simplify it. And in order to simplify it, we divide all the terms by cosine A on B, as we can see in this next step here, because this allows us to simplify it. So as you can see, we've got sine A cosine B, which is over cos A cos B, and that's being added, and we've got cos A sine B on cos A cos B, and this is all divided by, and then as you can see in the denominator, we've divided both of the terms by cos A cos B. And that's when we can start cancelling. We can cancel off cos B in the numerator, we can cancel off cos A's in the numerator, and then we can cancel off the bottom left term. And of course, when we cancel off the bottom left term, it's not going to go to 0, but we're going to get 1, because it's the same thing over each other. And of course, any number divided by itself is 1, so we treat that the same here. And what we end up getting as a simplification then is tan A plus B is tan of A, because it's just sine A on cos A, plus tan of B, of course, sine B on cos B there. And in the denominator we've got 1, because we were able to cancel it off. Take tan A, again, sine A cos A in the denominator there, and then we've got tan B. We then substitute in the values into the form we found, and we see that we get 5/6 on 5/6, and we can simplify this to 1. As a result, we know that tan Y equals 1, and therefore we can say that A plus B equals Y. Again, we know that tan Y equals 1 because of the angles that we looked at before when we established what tan alpha, tan beta, and tan Y were.